Good afternoon, mathematicians, and welcome. This video is going to be about equations of parallel and perpendicular lines. This is chapter 4.3. So during class we talked about a reciprocal, and the meaning of a reciprocal is the flipping of a number so that the product of both numbers is 1. Let's do a quick example. Let's say we have the number 2/7. Well, to find the reciprocal of that, we just need to flip the numerator and denominator so they change positions. So the 7 becomes the numerator and the 2 becomes the denominator. Now we can multiply those, and when we multiply them together, we should expect the product to be positive 1, always. So let's try it out. Our original number is 2/7, and we'll multiply that by our reciprocal of 7/2. Looking at the numerators, 2 times 7 makes 14, and in the denominators, 7 times 2 also makes 14. Any number divided by itself is always going to equal 1. Okay, so that works. Let's do one more example. So during class, we started doing -18, and we said, okay, well, that doesn't look like a fraction, but it actually is a fraction. It's the same as -18/1. So anytime we don't see a denominator, we know that it is 1, because -18 is a whole number, and 1 signifies being a whole, an entire something. Okay, so then let's look at our reciprocal. Again, we just switch the positions of the numerator and denominator. So the new numerator will be 1, and the new denominator will be -18. I do want to clarify that it doesn't matter where you put the negative sign. Let me erase it for just a moment. You can put the negative in the denominator, like we just had it. You can put it in the numerator, or you can put it out in front to the left of the entire fraction. As long as you only have one negative sign, this represents a negative number. So I'm going to keep it with the 18 just to be consistent. Alright, and the final step is to multiply. Again, we should expect to get a positive 1 as our product. So our original number is -18/1, and we will multiply that by our reciprocal of 1/-18. When we multiply -18 times +1 in the numerator, we get -18. And when we multiply +1 by -18 in the denominator, we also get -18. So not only do we know that a negative divided by a negative gives us a positive, but we also have 18 divided by 18. So we know that this is equal, in simplified form, to +1. So it does work every time. Alright, next, let's take a look at parallel lines. There is a symbol that we use for parallel lines, and that is this. The symbol kind of looks like the two L's in parallel, if that helps you remember. So the definition of parallel lines, let me draw that again. These are two lines in the same plane that never intersect, so they never cross each other. Let's look at a picture. Maybe we have line M here, and maybe we have line N here. We see that if we imagine these lines to continue forever in both directions, as lines do, they will never cross. They will never intersect each other. So I'm even going to draw these little arrows right here. If you see those little purple arrows on a line, that means, or on two lines, that means that they are parallel to each other. Okay, so quick note, parallel lines have the same slope. So if we look again at lines M and N, as we said before, these lines will never cross, they will never intersect, and they will always have the same slope as each other. And they don't always have to be horizontal or vertical, not perfectly. They could look like this, or any variation. Okay, so let me undo that. And let's look at an example. So I'm going to write two equations, and we want to know if the two lines are parallel or not. So equation 1 will say y equals 1/2 x plus 3. And the second equation will say y equals 1/2 x minus 6. So again, we are focusing on slope-intercept form, which is y equals mx plus b. Okay, that's the format that we're looking at for both of these equations. So let me actually move that. If it will let me, I'll erase it and write it up here, just so that it's out of the way. So y equals mx plus b. All right, so as we know, the m is our slope, and I underlined x. There we go. The m is our slope. So we're looking for the m in both of these equations. So in the first equation, y equals 1/2 x plus 3, the number that is being multiplied by the x is our slope. In this case, it's 1/2. Okay, I'll call that slope 1. In the second equation, y equals 1/2 x minus 6, again, we're looking for the number that's being multiplied by x, and that is 1/2. I'll call that slope 2. So let's compare these two numbers. We have 1/2 and 1/2. Well, those look the same to me. So since the slopes are the same, then these two lines are parallel. Okay. So again, one more time. These two lines are parallel because they have the same slope. All right, let's move on to our last definition, which is perpendicular lines. And that symbol looks like this. It's like an upside down capital T, perpendicular. Okay, so perpendicular lines are two lines in the same plane that intersect at a right angle. Okay, that should say a right angle. All right, and a right angle we know measures 90 degrees. So if we were to draw a picture, I'll call this line M, and I'll call this line N. These two intersect right here. And on any side, this side, this side, this side, or this side, doesn't matter. I prefer to write the symbol in the upper right, but that little square right there means that the angle measures 90 degrees. So you don't have to write 90 degrees, you don't have to write the arrow, it's just the square. That's what you will see. Okay, quick note, and let me just fill in this again, just so that it's consistent. Okay, quick note, the slopes of perpendicular lines are actually going to be negative reciprocals. So not only are the slopes going to be flipped, but one of those slopes will be positive and one will be negative. And we'll learn this a bit later, but that's what will get us the 90 degrees, it will get us the perpendicularity. So let's do an example. This time we want to know, are the two lines perpendicular? So equation 1, let's do y equals 2/5 x plus 4. And equation 2, y equals -5/2 x minus 1. Again, we're focusing on slope-intercept form, y equals mx plus b. And again, our slope is the m. So in equation 1, y equals 2/5 x plus 4, the slope is going to be 2/5. I'll call that slope 1. And in equation 2, y equals -5/2 x minus 1, the slope is -5/2. I'll call that slope 2. So let's compare these two numbers. We have 2/5 and -5/2. So first, I'm going to ignore the negative. Just for a moment, I'm going to pretend that's not there. Let me erase it. Okay, looking at these two numbers, we see that they are reciprocals, right? Flip the position of the numerator and denominator, and you get 5/2. So that checks. And then let's tack that negative back on there. Notice that our original fraction of 2/5, that number is positive. There's a +2 and there's a +5, so the entire number of 2/5 is positive. Looking at the second number, -5/2, so we've got a negative number over a positive number. That's going to mean that our entire number, or our entire fraction, is negative. It has a negative value, -2.5, if you will. Okay, so we see that the numbers are in fact reciprocals, and one of those numbers is positive, meaning this one. That entire thing is its own number, and one of those numbers is negative, meaning this entire fraction. Okay, so the two lines are in fact perpendicular because their slopes are negative reciprocals. And bonus challenge, try multiplying these two numbers together, these two fractions, and see what product you get, and let me know. Thank you so much for watching. Please let me know if you have any questions, and have a great day.